welcome to part 8 of algorithms in advertising. This one is called Productionalize it. Now, productionalize is a big software word, and we're going to make sure that everyone understands what it means to productionalize an algorithm or a machine learning model in an application by the end of this episode, right? And we're going to explain that by comparing the ad networks, the early ad networks that we talked about last time, with the first very successful predictive modeling algorithm and advertising company, which was Google. When we talk about Google today, we're going to be talking about Google in 2002, maybe older than you, but it's important to understand how Google started using algorithms in advertising and became the first smash success. So remember how in the network model we talked about last time, there are these processes that have to run. You have to collect all the impressions. You have to find all the conversions from the advertiser page, and you have to match the conversions to the impressions for each advertiser, right? Create your model and then deploy them for each advertiser. So the productionalize means make all that happen without human intervention all the time flawlessly, right? The hard thing about productionalizing a set of processes like I just described is that to productionalize something, you can never have unexpected results. You have to have code written for every possible thing that could happen. And when you're collecting impressions from 1,000 websites and conversions from 500 websites, right? If it's more, it's worse. Unexpected things can happen, right? The data could be in a different format, or a million other things could happen that weren't expected, that you didn't have code for, and the whole thing will break and require manual intervention. So when things are productionalized, everything is accounted for. Nothing is ever unexpected. Everything runs flawlessly without human intervention. This gives you the ability to run more cycles of the model, right? You could see what you predicted, see what actually happened, improve your model and update it when no one ever sees you do anything. It gets built in the lab and updated all at once, and everything continues to be smooth because all the data flow is productionalized, right? And the introduction of the model into the data flow is productionalized. So Google solves this problem in two very clear, simple, clever ways, right? Instead of 1,000 websites, Google, when it starts, one website, google.com. It was already successful as the best search engine, right? Because they were bringing a lot of machine learning, predictive, and ranking knowledge into search. By even the late 90s, they were known as the best search engine. And Google actually spent a couple of years trying to monetize google.com the way other websites monetized with display ads, and it was unsuccessful. And then they settle on this method of bidding on keywords and auctioning the ad space to appear on the keywords, right? So all the ads are keyword-based, triggered by searches on google.com. They all appear on google.com. No longer are you collecting you're collecting impressions from tons of websites. Secondly, in the first iteration of Google, all the conversions were also on google.com because Google cleverly replaced conversions with a proxy that occurred on google.com, which was clicks. Because it's considered a successful ad, if someone clicks on it, right, they visit the advertiser's page as a result of that click. That's a decent proxy for sales. At least it's some engagement with the brand and the ad. So that was a good enough proxy for sales that you could say all conversions are clicks. Now, the other innovation that Google bought was auctioning this space, right? And when you auction, it brings a lot of ability to rank ads for their effectiveness, right? Because the advertiser is constantly sending signals of what works for them and what they value through their bids, right? So Google is able to use bids to rank the ads on the page, to rank the advertisers who they might want to reach out to in person, and all kinds of other things like that, as Google has all the data within their house. No data is flowing outside, right? The term walled garden comes from the practice of not letting data out of your house, out of your garden. The walls mean that the data all stays inside. So this productionalization of Google, right? All the impressions are on google.com. All the conversions are clicks that occur on google.com. Every bid for a click is a quantitative value in dollars that can be quickly compared. Allows Google to very quickly iterate, right? So then run it over and over very, very quickly. And when you do that with a machine learning algorithm, it generates more data, more predictions, it gets better. And then something that happens in business, especially internet business, is that as you get better, you get more customers, which means you get more data, which again makes you better. That's called network effects. The more people who use it, the better it gets, which causes even more people to use it. And then it gets better again, and so on. A snowball effect called network effects in economics. So by 2004, only 2 years after the application for bidding on keywords called AdWords launches, Google is a household name, making a ton of money, and has a growth trajectory that still hasn't been replicated, hadn't been seen before, and still hasn't really been seen since. The predictions were so good that no one was able to catch up. The data that becomes in Google's house becomes so powerful that no one who doesn't have that data is able to build an algorithm anything like what Google has. The way we'll end this story is by talking about how powerful these network effects and ability to predict really were. So Microsoft, in the years between around 2004 and I believe 2007 or 8, is when they really stopped pouring money into the effort to build a search engine as good as Google. Microsoft search engine then is called Bing. Microsoft had way more engineers, machine learning capabilities, and data science capabilities to pour into Bing. There was no capability they were lacking. What they were lacking was users and data, especially on the long tail of searches, right? If you don't have data on who clicks the longer searches, right, the more detailed specific searches, you're stuck. You can't get it. You can't generate that out of nowhere. All predictive modeling in advertising is based on high volumes of data that enable better and better predictions, right? So the factors are the volume of data, the speed at which you can iterate, and the ability to productionalize with increasing complexity and volume, as Google does over the next few years. All right, so Google's success completely changes the industry by the year 2008, and that's what we'll start next time. We'll talk about the advent of programmatic, and remember, all of this explanation is by way of explaining to you why things are the way they are today with algorithms in advertising, where they strongly favor DR advertising, and that there's very little machine learning and algorithm built for all the other things that advertisers do besides DR. So write to me with any questions, as always, and be back soon with the next episode.